So arrays are a really critical data structure, and arrays exist in almost every programming language. So they exist in Java, but they exist in other languages too. Even though the syntax and how they work might be a little different, they exist in those languages. So it's really important to know about arrays, to be able to work with arrays. You're going to find arrays in any code that you work with that someone else wrote. And much of the time you'll use arrays yourself as well. But Java does give us one other option of a way that we can keep track of a collection of objects, and that's through the ArrayList class. So ArrayList is a class in the java.util package, so you need to import it from that package. And it's similar to an array in that it stores lists of values, each with the numeric index. Now the difference is ArrayList is a class, so arrays themselves are built right into the Java language. ArrayList is a class that comes again with the java.util package. Now, one big difference between arrays and an array list is that unlike an array, which we've talked about has a fixed size, an array list can grow and shrink as needed, adjusting its capacity automatically. So you don't have to upfront specify how big you want your array list to be. You can just keep adding things to it, and if it gets filled up behind the scenes, it'll automatically expand and get more space. So that's pretty great because we just saw that it's kind of a little bit of work to copy over an array and make it look like you're getting new space. So especially if you don't know in advance how big something needs to be, like let's say you're having the user enter in input, you don't know how many pieces of input they're going to give you, it'd be really tough to do that with an array. You'd have to constantly keep track of whether your array was full, and if it was full, you'd have to make it bigger and copy it over, right? All that work we just looked at a little while ago. That would certainly work, but it would be a little bit more difficult. An array list kind of does all that for you. So you can just keep adding things, and it'll just grow as needed. So there are lots of methods in the ArrayList class. You can take a look at them on the API page. So again, if you just Google Java ArrayList API, you'll get the page. And you can see all of the methods that you have. There are lots of them, so you can take a look at all of them. But here are some of the ones that are probably the most helpful. There are two versions of add. If you just invoke the add where you send in your element as a parameter, it adds it to the end of your list. Or you can specify what index you want it added in. So if you want it added in the beginning, you can specify index 0, for example, and then give the element, and it'll add that element in at the beginning. You can remove an element at a specific position. You can figure out the size, so this will tell you how many items on the list. Note that this is different from the capacity. This is the actual number of elements that exist in the array list. You can retrieve an element at a given position, and you can also test whether your list contains a specific item or not. So again, there are many more methods, but these are some really useful ones. Now, when you add something into an array list in the middle, what happens behind the scenes is that there is space made, and then everything else gets kind of shifted down, right? So if you have a list of 10 things and you want to add something into the 5th position, you need to move the 10th thing to position 11, the 9th to 10, the 8th to 9th, the 7th to 8th, the 6th to 5th, and then you can put the new element in at the 5th position, okay? So all of that work happens for you behind the scene with an array list. On the flip side of that, if you remove something from the middle of the list, behind the scenes, the ArrayList class will close that gap. So if you pull something out of position 5, we take what used to be in position 6 and shift it to 5, take 7, shift it to 6, take 8, shift it to 7, 9, shift it to 8, 10, shift it to 9, to basically close that gap. And all of this happens for you. Okay, so all of these the indices are automatically updated, makes the ArrayList class pretty user-friendly, pretty great. Obviously, all of this you could do with an array, but you'd have to manually do that shifting and close that gap yourself. Now, note that again, with an array list, just like with an array, our indices start at 0. So the first element of an array list is at position 0, not position 1. Now, array lists and arrays actually have pretty much the same efficiency. That's because behind the scenes, whoever wrote the ArrayList class for Java did it with an array. So an array list, as the name might imply, actually does use an array. It's just that all of that kind of shifting and expanding work is done for you. So the nice thing is you don't have to worry about writing that code. It's done for you. You just get to use it, but you don't really gain anything in terms of efficiency, because behind the scenes, it is still implemented with an array. Okay. So if when you're thinking about that, you can kind of think about it in the same way you would think about an array. So if you're adding elements mainly to and from the end of the list, that means you don't have to do a lot of shifting or a lot of closing of gaps. So it's pretty efficient to use in an array list. But if you are going to be constantly adding and removing things from the middle of your list, that is going to be a little bit less efficient. And there are other data structures that might be a little bit more efficient for that particular purpose, but we're not going to go into that in this video. But just keep in mind that an array and an array list have essentially the same efficiency. There's a little bit of overhead associated with an array list because it uses an external class, as opposed to arrays are kind of directly built into the language itself. But in general, they're pretty comparable. Now, array lists use something called generics. Generics is a newer addition to Java, relatively speaking, and we're not going to talk about generics too much in this video, but we're only going to talk about it enough as how it applies to array lists. So array lists in general can store references to any object. That means essentially anything that's an object, meaning anything that isn't a primitive, could be put into an array list. But usually that's not what we want to do. Usually we want to have a list of one particular type. So just like we specify our arrays to hold ints or to hold strings or to hold booleans, we usually want to do that with an array list too. It's very uncommon that we actually want our list to hold a number and a string and an audio item, right? Usually that doesn't make sense. Usually what we want to do is we want to restrict our array list to only hold one kind of object, and generics is what lets us do that. So to use generics, instead of just declaring the type of our object to be array list, we're going to put the type that we want to restrict that array list to hold inside of these little caret brackets. So if we want a list of strings, we can say array list, open caret bracket, string, close caret bracket as the type. So this now says that our array list can only hold objects of type string. And if we try to put something else in that list, like an audio item, we'll actually get a compiler error. So the compiler actually won't even let us put something in there. So I'm going to recommend that even whenever you use array lists, you do so with generics. It's not necessary. Like, you will be able to compile and run your code without this, but you'll have to do a little bit more work to get things off of your list. And it's also just not great practice. It's much better practice to specify what you want your list to hold and stick to that particular type. So let's do a little bit of practice so you can see the array list in action. So we're going to write a method to read some numbers from the user and keep track of them in an array list. Okay. The user is going to enter 0 when they're done adding numbers, and then we'll print out some information. We'll print out the number of numbers that they entered, the sum of the numbers, and how many numbers were even. So one other note about array lists is they can only hold objects, so they can't hold primitives. So in our case, if we want an array list to hold numbers, we'd have to use the wrapper class. We won't be able to add a primitive integer to the list. We'll have to add a capital I integer. So that's one of the purposes of those wrapper classes, is that whenever you want to use a primitive value, but you need an object, you can use the wrapper classes, and array list is one of those times. So, okay, so let's create our array list, and it's going to hold capital I integers. So again, it can't hold ints. This is not allowed. You'll see we're getting a compiler error there. It can only hold objects. So we're going to have it hold integers. I'll call it my number list, and I'll initialize it just like I would any other object with the new keyword and a call to the constructor. Now, because I'm using generics here, I have to also use it in my constructor, and there's two options for how I can do that. I can actually list the type again, like that. Or note that starting as of Java 7, you can actually leave this second type off, and that's allowed as well. But note, importantly, you do still need those caret brackets. So if you're worried about forgetting those, you can just leave that whole type in there. That's just fine. And of course, we have to import this class. It doesn't come automatically, so we need to import it from the java.util package. Okay. I'm going to import the whole package because I'm also going to be using scanner. So we'll tell our user, begin entering numbers, enter 0 to quit. And we'll do this while they're still entering. So I'm going to create a Boolean variable, still entering. It's true. And while they're doing that, we will read in a number. So we'll say scan dot next line, which will give us a string, and then of course we'll parse that. Now I'm not doing any error checking to make sure the user is actually giving me a proper number, so just take note of that. Of course I need my scanner object. Okay, so what I'm going to do is I'm going to add this number to my list. Now, some of you might be thinking, hey, I thought you just told me we can't add integers into ArrayList. And that's true. This ArrayList can only hold capital I integers, not primitive ints. But remember, one of the nice things about the wrapper classes is that auto boxing and auto unboxing, which means that primitives can be automatically converted from a primitive to their wrapper class object version and vice versa. So what's actually happening here is that behind the scenes, user number is being converted into a capital I integer and then added to the list. So I can add it in this way, but just note that actually what's happening is it's being added as a capital I integer, not as a primitive. Again, I could not do this. This is not allowed. I'm not allowed to store primitive values in an array list. Okay, so actually we need to add a little bit more housekeeping code here. We need to say if the user number is not equal to 0, then we'll add it. And if it is equal to 0, then the user is done. Okay, so that takes care of this first part. We're just going to keep track of all the numbers that the user has entered. So then when it's done, we want to print out all of the numbers that they've entered. So unlike an array, we actually can just print a list out in a print line statement, and it's going to give us a nicely formatted output. Let's actually take a look and test this right now so you can see. Okay, 5, 6, 3, 4, 2, 1, 0. And there's my nicely formatted list. So you'll notice this prints out with the same formatting that the arrays.toString used for the regular arrays. Same formatting. It's all on one line, comma separated. Okay, so we've kept track of the numbers. So now we want to print the number of numbers entered. So there's the list. You entered. And we can access the size of that list by invoking the size method. Okay. Now we want to know the sum of all the numbers. So to sum up all the numbers, we have to iterate through the list to get each value and to total it up. So we're going to say our total starts with 0. Now I could use a regular for loop, but if all I'm doing is accessing the elements in my array list, I actually also have that option of using a for each. I'm going to encourage you to really think about using the for each or the enhanced for whenever you're working with array lists. They're much preferred for this kind the array list object. So I'm going to say for each integer I in my number list, I'll just increment the total, and then I can print out the total. Okay, so here you can see the structure of the enhanced for or the for each is exactly the same as it was for a regular array. So the setup is the same. It's just you're now working with an array list instead of an array. And then the last thing, we want to count how many numbers are even. So I could actually do this in the same loop. So I'll say if I mod 2 is 0, I will increment number of evens. Okay. Okay, so let's run this again. 1, 2, 5, 7, 8, 10, 9, 8, 16, 4, 3, 0. So there we go. So that's a little bit of practice with array lists using integers. And we're going to do another example. So I'm actually going to move this into a method. and we'll comment that out. So now we're also going to write one to do a little practice with strings. Okay, so for this next practice, we're going to write a method to have the user add strings to a list, and if the word is not in the list, we're going to add it. So essentially we want to avoid adding duplicates, and when the user enters quit, we are going to be done and print the contents of the list. So we are going to start out similar. Create an array list. This time it's going to hold strings. Okay, so note that the type of this list is string. And okay. Okay, we'll have some. Okay, so while we are still entering, we'll read in a word. Now, we have to, first of all, make sure if it's equal to quit. So if the user word equals quit, then we're done. But otherwise, we want to check to see if the list already contains that word. So we could say, okay, well, if the word list dot contains the user word, then we just don't do anything, right? Or on the flip side, probably a little better approach is we could say if it doesn't contain it, then let's add it. Now this will add it to the end of the list, which is fine because we never said anything about the ordering. But if we wanted it to always add it to the beginning of the list, we could do this. If we always add to position 0, then the new word the user enters will always be entered into position 0, and the old words will get kind of shifted down to make space. And then at the end, we'll print the word list. Okay, so let's run this. So I'll put some in, let's see, this is my sentence, so you can see the order, and then I'll put in some duplicates as well as another random word, and quit. So you'll notice that the last word I'd entered in, apple, is first because I was always adding to the beginning. The words, they're kind of in reverse order, and no duplicates. Okay. So there's a little bit of practice with array lists. The bottom line on array lists is they're great. They're great to use. They're really user-friendly. It doesn't mean you should never use an array, especially if you have something that is always going to be a fixed size. So let's say, for example, you have 10 spaces for students in a class, and that's a fixed size. It's never going to be larger than 10. Then it probably makes sense to use an array and not an array list because you don't want it to always be continually expanding and shrinking. Okay, so anything with a fixed size you might find more efficient, or from a programming perspective a little bit easier to use an array. But anytime you want the size to grow or shrink, you should definitely consider using an array list, and most certainly always use it with generic so that you're restricting your array list to only one type of object.